safety and efficiency. TMMK covers about 7.5 million square feet of space, with the equivalent of about 156 football fields under roof. This is one of the most complete vehicle manufacturing plants in the world. TMMK's production process starts in die manufacturing. By using everything from computer-controlled laser technology to hand grinding tools, these team members bring the designer's plans to life, with quality measured within 0.02 of a millimeter. Once complete, the dies come to stamping, a shop that covers about 700,000 square feet. The dies will be loaded into one of more than 30 presses in the shop to do their jobs. It takes about 20 hours to complete one of our vehicles, once stamping begins to make the nearly 300 sheet metal parts needed for each vehicle. Stamping's work begins with these giant coils of steel weighing up to 24 tons. Team members on the floor move the coils using a remote control overhead crane. The coil is loaded into one of our 4 blanking machines, which straighten and clean the metal. Then the machines cut the metal into blanks. The blanking machines cut the steel at a rate of 80 strokes per minute, using a force of nearly 800 tons. The finished blanks are fed into stackers that automatically stop at the beginning and end of each production process for a quality check. This is one of the many times we will check the quality of our vehicles during the production process. Every team member at TMMK is an inspector. While doing their jobs, they inspect the product to make sure that no defects are passed on to their customer. At Toyota, the customer is not only the person who buys the finished vehicle, but also the next team member in the production process. When blanks pass inspection, they're moved to storage by a forklift operator. They stay there until they're needed on the stamping lines. Then the driver will deliver the blanks to the press. In stamping, TMMK uses more than 20 automated press lines and more than 30 presses, loaded with some 900 dies. Weighing as much as 40 tons each, these dies come together with up to 2,600 tons of pressure to bend, shape, and trim the blanks into formed vehicle parts. To withstand an impact so strong, the floor beneath the presses is nearly 3 feet of solid concrete. The larger presses also rest on several concrete pillars that go as deep as 30 feet below the shop floor. In this basement, metal scraps trimmed from the parts during stamping fall onto a conveyor and are collected for recycling. Throughout our plant, we recycle and reuse as much material as possible in order to be a good steward of the environment. When a different part is needed, die changes are required. For many plants, this is a time-consuming process, but at TMMK, we have the process down to about 10 minutes. At the end of our stamping lines, team members inspect the parts as they come off the presses. Once approved, the parts are stored for a short time until they're needed by our body weld department. In about 2 hours, body weld builds a complete body shell. This shop covers about 1 million square feet and is the most automated part of our plant. Its team members work with some 700 robots. Body weld is divided into 4 lines: underbody respot, underbody tacking, main framing body, and body shell. Here in the underbody respot line, 3 major sections of the underbody come together: the engine compartment, the front floor, and the rear floor. Then the underbody will move to the main framing body line, where it will join to the quarter panels, the roof, the cowl, and the upper back of the vehicle. Alongside team members, more than 70 computer-controlled robots perform the thousands of precision welds required on this line. Next, the vehicle bodies are lifted onto the overhead conveyor and taken to the body shell line, the last line in body weld. On the body shell line, team members attach various parts, including trunk lids, doors, hoods, and fenders. After final inspection and approval, completed body shells travel by conveyor to our paint shop, or they may head to shipping. If they are among the more than 350 replacement parts that our stamping and body weld shops supply to dealers and other customers around the world, these shops produce repair parts for our vehicles for at least 10 years after Team MK stops production of a model. Here in paint, a body shell gets what will be one of the vehicle's most defining qualities, its color. And we guard the quality of that paint job very closely. Throughout paint, care is taken to keep debris out, because even one speck of dust can ruin a paint finish. As team members enter the shop, they don special lint-free clothing and walk through an air blow room. The air removes any loose hair, thread, or material that may diminish the quality of our paint jobs. These team members working in paint also must be mindful of how personal products might affect the paint process. Our paint process takes about 10.5 hours to complete, starting when a completed body shell is pulled from body weld. The pull system is an aspect of the Toyota production system's just-in-time concept. When material or a component, like a body shell, is needed, it's pulled to the shop, not pushed, as in many traditional manufacturing facilities. By pulling instead of pushing, we produce only what we need, when we need it, and in the amount needed. Painting at Toyota involves 8 basic processes, but first the body shell must be cleaned. A series of dips into tanks removes dirt, grease, and other contaminants from the surface. Then the painting begins with a dip into the phosphate tank, a process that etches the body shell so primer and top coat will better adhere to it. Next is the ED dip. Electrode deposition is an electronically charged primer that permanently bonds to the shell. After ED, the body goes through a series of rinses, then is oven baked at nearly 500 degrees. Next, in dry sand and sealing, team members smooth rough spots on the body surface. Then robots apply a seam sealer to prevent corrosion and water leaks. The fourth process in paint is anti-chip. Here, a coating is applied to the bottom of our vehicles where they will receive the most road damage. In the next process, primer is applied to smooth out the appearance of previous layers. Then the body shell is baked again, this time at more than 250 degrees. The sixth process in paint is wet sand. Here the shell will get its final preparation before painting, with team members inspecting it and removing any last imperfections. Next, the vehicle gets its top coat in one of 3 paint booths. This area is another example of Toyota's commitment to the environment. Our paint robots use a unique cartridge and water-based system that lets them quickly switch between paint colors with little waste of paint or the use of harsh chemicals. The robots also are programmed to paint along the contour of the vehicle. This reduces the amount of overspray that enters our reclamation system. Next, the painted shell is baked again, this time at around 250 degrees for about a half an hour. Then the painted body is checked for any imperfections at the 8th and final process, final inspection. There, approved vehicles go to the selectivity bank, ready to be pulled to assembly when needed. While the body shell is being welded and painted, our powertrain shop is building the vehicle's engine. TMMK produces more than 2,000 engines a day on site. We build both 4- and 6-cylinder engines in this 1.2 million square foot shop. Powertrain's raw materials include engine blocks and heads that come from our suppliers. TMMK has more than 350 suppliers in North America, over 100 of which are located in Kentucky. Powertrain machines its camshafts, crankshafts, connecting rods, cylinder blocks, cylinder heads, cam housing, and piston pins from our suppliers' rough castings. The machine components are sent to short block subassembly first. Here, team members install the crankshaft, pistons, and piston pin assemblies. After the engine receives a balance shaft for vibration reduction, it moves to lower assembly, the second assembly process. Next, a team member positions the oil pan, just before a machine inserts and tightens the oil pan bolts. If the machine detects any problems, it will stop and send a signal to alert the team leader. This is another key part of the Toyota production system. Jidoka is our practice of stopping production whenever a problem is detected. Many of our machines will automatically do this, and our team members can do this as well to keep any flaws out of our products. Next, a team member installs the timing belt, timing cover, and oil and water pumps. As the engine moves down its line, team members confirm their work and that of previous processes. In the final production stage, the engine gets its cylinder head, wire harness, intake, and exhaust systems. Once completed, the quality of our engines is confirmed in a test cell. Here, the engines are subjected to several tests as team members evaluate them for noise, emissions, and any abnormalities. Approved engines are sent to a shipping room, which holds a 2 to 3 hour supply of engines. Team members of our conveyance team will come to collect the engines that are needed, when they are needed by assembly. They'll be delivered just in time. Our assembly plants also get parts from our on-site plastic shop. In this 517,000 square foot shop, team members produce components for our vehicles, including interior trim, rocker panels, manifolds, front and rear bumpers, and instrument panels. Making the instrument panel, or IP, starts in the injection molding area, where plastic pellets are melted and then injected into a mold under several hundred tons of pressure at more than 400 degrees to form the instrument panel's skeleton, which we call a substrate. Nearby, in the slush molding area, molds are filled with a very fine powder and are heated and cooled over several processes to create the skin of the instrument panel. In plastics, IP assembly team members combine the skin and substrate and add padding made of recycled materials, as well as other parts from within the shop and from vendors. Also in the shop's injection molding area, team members make trim for the vehicle's interior and produce the manifold. They injection mold each piece, then combine them using an ultrasonic welder. Robots load the parts into the machine, which uses high-frequency sounds to weld them together. Then the manifolds pass to the manifold assembly line, where they are fitted with gaskets and parts to ready them for vehicle installation. This shop also makes vehicle bumpers. After they are formed by injection molding, the raw bumpers are primed and painted in plastics in much the same way as the vehicle body is painted in our paint department. Rocker panels are also created and painted in this shop using the same process. While plastic supplies assembly with these two parts, the shop also ships them to our sister Camry plant in Indiana and to dealers as service parts. TMMK Plastics ships about 1,000 service parts each day. We supply service parts for up to 21 years after the production stops for a model. The machines and plastics are kept running by the shop's maintenance team members, while another set of skilled tool and die team members repair molds and dies. At the end of each plastics process, team members inspect their parts for quality and then load them onto a parts carrier for delivery to the next process, including assembly. TMMK's assembly shops are the largest in the plant, covering nearly 2 million square feet. Assembly 1, our original plant, builds Avalon and Camry, while Assembly 2 produces Camry and Venza. Each shop is comprised of 3 operations or lines: trim, chassis, and final. Assembly's work begins when it pulls a newly painted body shell from paint onto the trim line. Trim installs parts largely unseen by customers, like wiring harnesses, onboard computers, and padding that will keep the vehicle's interior quiet. At the beginning of this line, a team member places a manifest sheet on each vehicle. This sheet tells team members which parts and which options to install on each vehicle coming down the line. Here the car also gets its set of keys. They will travel the length of the line with the vehicle. As parts for each vehicle are needed, they are delivered line-side by our conveyance team members. Parts arrive from our suppliers constantly throughout the day, orchestrated by our production control department. Using our just-in-time system to minimize inventories and floor space, the plant typically stocks on-site only the parts needed for about 3 hours of production. As parts arrive, some go directly to the line, like seats, which are already in perfect order to match the vehicle in which they're going to be installed. Most parts, however, are brought here to our dock area, where team members sort and prepare them for the line. They'll box some parts for a particular vehicle together into what we call kitting. Kitting involves parts that are small or difficult to differentiate between models. That kit will be delivered to the assembly line and often travels with the vehicle once it's picked. Kitting lets team members focus on a quality installation. As the vehicle works its way down our assembly trim line, it gets one of its most important features, its VIN, or Vehicle Identification Number. This machine is striking a series of numbers and letters onto a metal plate. This VIN is installed at the base of each windshield to permanently identify the vehicle. Here, a team member installs the side curtain airbag, one of the first of up to 10 airbags that will be installed depending on the vehicle model. One of the first Japanese words and concepts that our team members learn at Toyota is Kaizen. It means continuous improvement and is a hallmark of the Toyota production system. Every team member contributes to Kaizen. Here is a great example of Kaizen. When TMMK began production in 1988, the doors stayed on the vehicles throughout the assembly process. Several years later, following a team member's suggestion, we implemented a Kaizen and removed the doors. Now, team members don't waste motion and time walking around the doors or constantly opening and closing them, nor do they chance being hurt by walking into the doors. The Kaizen also reduces the possibility that the doors themselves will be damaged. And it lets us move parts racks closer to the line, again reducing the team members' motion and time. This Kaizen, developed by a team member, helped improve safety, ergonomics, quality, and productivity all in one. Once taken off the vehicle, the doors travel by overhead conveyor to a trim subassembly line called the door line. Here, windows, padding, locks, speakers, and other components and options are installed. With the doors now at eye level, team members can complete their work easier and safer. The doors then head into an overhead conveyor system until it's time to reinstall them to the vehicle on the final line. Meanwhile, the doorless vehicle continues its assembly process on the trim line, where the hood insulation is installed. This padding helps keep engine noise in the passenger compartment and outside of the vehicle to an absolute minimum. TMMK builds hybrid versions of many of its models, and here the main hybrid battery is installed. Weighing more than 50 pounds, the battery is placed in the vehicle's trunk with the help of an assistant. Devices like this are used throughout our plant to help keep our team members safe and injury-free. Trim also installs the headliner, moonroof trim, and visors. Hanging just above the line, near our team members, is an andon cord. Our team members have a certain set amount of time to do their jobs. We call this tack time. If they have a concern or encounter a problem that keeps them from meeting that tack time, they can pull the andon cord and call for help. Pulling the andon cord activates tunes, lights, and boards that tell team and group leaders that they're needed and where. They'll respond and try to address the concern without stopping the line. But if they can't do that within the takt time, they will pull the cord again and all of production stops. Or, if need be, they'll take the vehicle offline to make any needed repairs. Next, in trim, the vehicle gets the instrument panel that was made for it in plastics. When the IP left plastics, it came to the IP line, another sub-assembly line here in trim. Here, team members install, among other components, air conditioning ductwork, controls, gauges to monitor speed and fuel, stereo options, and the steering column. Once the IP is complete, an automatic guided vehicle, or AGV, delivers it line-side for installation into the vehicle. These smart cards are made by team members and follow a magnetic strip in the floor to their destination. Team members use a hoist to install the IP into the vehicle. Team members also use a hoist to install the rear struts, which can weigh about 70 pounds each. These devices greatly reduce the ergonomic burden on our team members and help ensure a quality installation. Trim also installs the vehicle's axles, parts which are built on site by our powertrain shop. Next comes the gear shift and the rear tail lights. Team members on this line also place the Toyota and model emblems carefully onto the vehicle. With trim's work complete, the vehicle moves to chassis, a line that is elevated because its work is underneath the vehicle. Chassis team members install fuel lines, brake lines, and the engine built just for this vehicle in our powertrain shop. Powertrain supplies the engine block to the engine line in assembly. This sub-assembly area will build up the engine block with the air compressor, alternator, and the vehicle's transmission, along with other components. A lifter holding the engine sub-assembly then moves under the vehicle where it's hydraulically raised into the engine compartment. Team members bolt the engine to the H-frame and body and then attach the axles. The exhaust and muffler assemblies are installed afterwards. Also in chassis, the vehicle gets a radiator, rear speakers, seat belts, and carpet. Here, a quality control team member inspects the work of chassis, helping to ensure that only the best work is shipped on. The wheels and lug nuts are installed by this machine, a nut runner. It's used to ensure that all the lug nuts are tightened to the exact torque needed. The nut runner features a poke-yoke. A poke-yoke is a fail-safe device that detects defects and prevents them from being processed any further. Poke-yokes are used in conjunction with many pieces of our equipment, especially critical processes, to ensure safety and quality. At the end of chassis, the vehicle moves to the overhead conveyor, where a robot places the spare tire into the trunk. Then the vehicle descends to the final line, where robots also help team members install the traditional battery. One robot places batteries onto a conveyor, while the next installs the battery into the engine compartment. Robots also help final line team members install the vehicle's windshield and rear window glass. This final line team member is installing the center console with the help of a floating chair called a raku seat. Another example of our just-in-time manufacturing is our seat installation. When the vehicle bodies leave our paint shop, information is sent to our seat supplier, also located in Georgetown. They build the seats and ship them in sequence to match the order of vehicles on our assembly line. An overhead conveyor brings the seats directly from the delivery truck to final for installation. Then the doors are reunited with their original vehicle. Final also installs the coolant, windshield wiper fluid, steering wheel, windshield wipers, headlights, and the bumpers. The vehicle gets its first gasoline on final line. It enters this concrete block room where a few gallons of gasoline are pumped into the tank. Under these bright lights, team members inspect every inch of the body surface and interior closely to make sure that it meets Toyota's high standards of quality. At the end of this line, a quality control team member drives the vehicle off the line and across rumble strips. These create vibrations, which will expose any rattles or unacceptable noises. The team member positions the vehicle on the toe adjust to adjust the steering wheel, as another team member in the pit below aligns the vehicle. Team members then test the vehicle's functionality on a roll drum. As the vehicles move from 0 to about 80 miles an hour, team members check for proper gear shifting. Next, each vehicle travels through a water shower to check for any leaks. In one of the last assembly processes, the driver's steering wheel airbag is installed. With this installation, the vehicle's airbag system is initialized. Randomly selected vehicles from our daily production are taken over to our audit lab and test track. In the lab, team members run quality assurance tests to check for everything from water leaks to audio system functionality. At the test track, highly trained team members drive the vehicles at speeds up to 85 miles an hour around our track and over special surfaces. This process confirms everything from engine performance and handling to passenger comfort. We inspect every aspect of these vehicles to ensure that only the best quality vehicles leave our plant. Back in the plant, each vehicle rolls off the line. Our customer, Toyota Motor Sales, buys it from us. A film is added to protect the vehicle during transport. Then the vehicle leaves our plant for the marshaling yard. From there, our vehicles are shipped to Toyota dealers across North America and the world.